Even though both Voyager 1 and Voyager 2 spacecraft began their missions back in 1977, we are still receiving a lot of valuable information from them. They have been in service for 45 years, such a number used to seem impossible. Both spacecraft were originally planned to explore Jupiter, Saturn, and parts of Neptune and Uranus. No one expected that Voyager would exceed the plan. Now they have already crossed the heliosphere, and to leave the entire solar system behind, they just need to get past the Oort cloud. Each Voyager has its own power sources. These are cylindrical structures containing 4 to 5 kilograms of plutonium. They're called radioisotope thermoelectric generators, and each Voyager has 3 of them. The plutonium produces 2,400 watts. They first produce heat, which is then converted into electrical energy. Since the power sources were installed 2 years before Voyager began its missions, they've been running for 47 years. As you can imagine, the operational lifespan has to come to an end at some point. You also have to add the impact of the external environment and neutron radiation, which occurs during the decay of plutonium. This ultimately leads to the deterioration of both spacecraft, and over time, they will transmit increasingly weaker signals. A decrease over 88 years, which leads to the generator's performance being reduced by half. At the same time, they have to keep all the components running and deliver information to our planet. The maximum amount of memory that the camera images can occupy is 67 megabytes. The devices have 8-bit processors with a clock speed of up to 6.4 MAT. That's not much considering that, for example, our smartphone has about 380 MHz. Despite this, Voyager managed to gather a lot of information and still continues to do so. How did the Voyager project come about? These probes made important scientific discoveries. What does the sound recording of interstellar space sound like? And what will happen to these legendary spacecraft in the future? HBO. The story begins in 1964. Edward Carroll Stone, at that time an intern at the Jet Propulsion Laboratory, came to this conclusion while modeling the positions of the planets for the coming decades. At the end of the 1970s, the planets that were beyond the asteroid belt would come together in a small part of the sky. This would make it possible to approach each planet in turn using only gravitational maneuvers to study them all in a short time. Bodies. We could fly by everything in 8 years instead of 13. That's exactly why we could get more valuable information. Partly thanks to such a discovery, the Voyager project appeared. From Earth, it was impossible to observe most of the planets, even with powerful devices. That's why the data obtained by the Voyagers during their missions is so valuable to the scientific community. In 1979, Voyager 1 was already close to Jupiter. That's when we got images of the well-known Great Red Spot. Voyager 1 also is visible from Earth. At the same time, it discovered that Jupiter has a ring system. Before that, scientists didn't know about it. Then the probe began studying Saturn. In 1980, the probe reached its closest distance to the planet, 64,000 kilometers, flying up to the upper clouds. The probe took high-quality photos of Saturn's rings and some of its moons, and sent the data back to Earth. The temperatures on the planet itself were quite low. In the upper layer of the atmosphere, it dropped to minus 191 degrees Celsius. The warmest spot near the North Pole had a temperature of minus 10 degrees. Very strong winds were also observed closer to the equator, moving at a speed of 1,800 kilometers per hour. Voyager 1 also happened to be near Saturn's moon, Mimas. It was notable for having a huge crater with a diameter of about 100 kilometers. At the same time, the diameter of the moon itself is just under 400 kilometers. In the Saturn system, the last spacecraft studied the moon Titan. The minimum distance between them was 6,490 kilometers. As a result, it was found that Titan is not the largest moon in the solar system, although scientists previously believed so. The honorary title went to Ganymede. Voyager 2 also studied the moon's atmosphere, and it turned out that its density was higher than initially thought. The data suggests Titan may have different types of bodies of water, but they would be made of liquid hydrocarbons. The fact that the probe got so close to Titan did not go unnoticed for it. After that, it could no longer study other celestial objects. Meanwhile, Voyager 2 was heading toward Neptune. It also got very close to it, at a distance of just 5,000 kilometers. We received an image of Neptune where you can see an incredibly large spot closer to the equator. According to calculations, even Earth is twice as small. What is this? This is an atmospheric anticyclone. Its appearance specifically on Neptune is not surprising, since the planet itself experiences the most powerful winds in our planetary system, 2,400 kilometers per hour. Voyager 2 discovered 4 moons. Triton was also studied, and it turned out to have geysers, and they are actually active. This was unusual for an object located so far from the Sun. The main objectives of Voyager were completed, but they continued to operate further. In 1990, we received many images of the solar system from Voyager 1. One of the most famous was a photo called the pale blue dot. That dot was our planet, only it was taken from a distance of about 6 billion kilometers. Being so far away, we see the Earth as a blue, unremarkable speck. By 2011, Voyager 1 had traveled as far as 109 astronomical units from Earth and entered the stagnation region, a zone with a strong magnetic field beyond which interstellar space begins. In the stagnation region, there is an increased level of high-energy electrons. They enter there from the interstellar medium, which allows us to call this area the outermost part of our planetary system. However, even after reaching such a distance, the probes continued to make discoveries. 8 years later, in 2019, Voyager 1 neared the edge of the stagnation area, getting as close as possible to interstellar space. Meanwhile, the probe's instruments detected a 25% rise in galactic ray intensity, showing the spacecraft neared the heliosphere's edge. It is now confirmed that Voyager 1 is already traveling through interstellar space. What's going on with Voyager 2? When the spacecraft was near Neptune, the planet's gravity changed the direction of the probe's flight. As a result, Voyager 2 moved away from the plane of the ecliptic and could no longer approach other planets in the solar system to study them. Nevertheless, this did not make the spacecraft useless. In 2018, it crossed the heliopause, the region that is considered the boundary of interstellar space. Thus, we were able to obtain important information from both spacecraft about cosmic winds and the properties of interstellar plasma, as well as the sounds of interstellar space. Let's focus on the latter in more detail. The plasma wave sensor on Voyager 1 detected some oscillations of ionized gas in the region of interstellar plasma. Scientists were able to determine the intensity and loudness of these sounds. This data also helps to determine the density of regions of interstellar plasma. These sounds are in a range that can be heard by humans as well. We recommend doing this now with the Voyager wave sensor. Amazing, isn't it? However, even though Voyager may not send new data to Earth for several months or even years after some time thanks to them, we will once again learn many amazing and sensational things. In 2022, a constant, though very weak signal was detected between bursts of solar radiation. It is assumed that fluctuations in interstellar gas triggered the formation of plasma waves, where this hum was created. But what is it? It was previously assumed that the low-level activity occurring in the interstellar medium was lower than it actually turned out to be. While we may call this area a vacuum, the exact reasons for the increased activity remain unknown. Some theories suggest this was caused by quasi-thermal noise from electrons in the plasma, or by plasma oscillation showing thermal activity. By studying this signal, we can also determine how dense the plasma is in the interstellar medium. Voyager detected an increase in electron density in this area. This will help scientists in the future to learn how interstellar plasma is distributed and how it is affected by solar winds. Unfortunately, most of the sensors and instruments are currently turned off on both probes. Only those that study the properties of plasma are still operating. Before Voyager's energy is completely depleted, scientists will extract absolutely all the data that both spacecraft have collected. Despite this, the radioisotope generators will continue to produce heat for some time. This could be about 880 years or 10 half-lives. Then the plutonium reserves will be completely depleted, and we will never hear anything about these amazing devices again. The devices are moving in one direction, and together they will pass through the Oort cloud, where they may be damaged. But we hope that doesn't happen. After that, the devices will fly in different directions to distant cosmic objects. Sadly, we may never know what they discover there. We received an image of this cosmic object back in the 1970s. In it, you can see Jupiter's moon, Europa. What important discovery were scientists able to make thanks to this image? If you look closely at the images, you can notice cracks encircling the entire surface, which are about 1.5 kilometers wide. It is quite possible that they were caused by the tidal forces of the internal ocean, which tore apart the upper layer. This suggests that the upper layer of this moon is mostly composed of water ice. As early as 2012, water vapor was detected in the southern part of Europa. It formed something like plumes that were 200 kilometers high. Scientists are confident that thanks to this phenomenon, we can learn about the internal structure of the moon without sending landers there. In this video, we will look at extraordinary phenomena on Jupiter's moons. Why does Europa have no impact craters? Which moon has the most breathtaking view in the night sky? Why are there entire lakes filled with lava on Io? And where is Valhalla, the largest crater in the solar system? Most researchers agree that at a depth of 15 to 25 kilometers, there could very well be a huge ocean that may extend as deep as 160 kilometers. Europa may even have more water resources than our planet by 79%, even though Earth is much larger. There could also be living organisms in the ocean that lies deep within the moon. It is believed that the surface is covered by a layer of ice. If we look at the images taken by the Galileo spacecraft, we can clearly see dark areas that are about 10 kilometers in diameter. The reason for their formation is that substances with high temperatures but lower density rose up, thus exerting strong pressure on the crust, or trying to break free. The terrain on the satellite itself is quite uneven. Such irregularities are called chaos terrains, and their identification is marked by areas where the surface is smoother. They are divided into equal parts by a belt of calgospore spikes, which are made of ice and are about 15 meters long. Similar objects can be found on our planet as well, but they mostly form in high-altitude regions with a dry climate. Nevertheless, they do not reach the same impressive sizes as those on Jupiter's moon. An interesting phenomenon is the terrain of Europa. For comparison, the terrain of the moon consists of numerous craters. Their number exceeds 5,000, and their average diameter is more than 25 kilometers. No impact craters have been found on the surface of Europa, despite the great age of the moon, which has long surpassed 50 million years. So, what could this tell us? The absence of impact craters may indicate constant changes occurring in the upper layers of the object. Since Europa is a moon with one of the smoothest surfaces in the solar system, it has a high level of brightness, even greater than Earth's moon. Radiation waves from Jupiter reach Europa with a frequency of about 0.3 MHz, and their amount would be enough to destroy a human. Let me remind you that radiation at 4 sieverts can already be lethal. The distance from the Sun to Europa is 5 times greater than to our planet, so sunlight barely reaches the moon. Accordingly, there is permafrost on the surface, an area where periodic thawing does not occur, and the temperature usually drops to minus 160 to 220 degrees Celsius. In the 1970s, the well-known spacecraft Voyager 1 flew near another moon, Io, which has a rather rocky terrain. The space probe noticed that the surface of the object is full of volcanoes, more than on any other in the solar system. Io is the 5th moon of Jupiter. Its approximate age reaches 4.5 billion years, which is actually about the same as the giant planet. Its size is almost the same as the moon. Besides that, they have other common characteristics. They have almost the same gravity and density. Most moons in our planetary system are made up of silicates and water ice, but Io is an exception. It consists of silicate rocks and iron elements. It is also remarkable that this moon has auroras whose brightness changes in intensity due to its rotation around Jupiter. However, the auroras never fade away. Despite the fact that the distance between Io and Jupiter is 420,000 kilometers, this is not very much compared to other objects. For example, the distance between Jupiter and Europa is 670,900 kilometers. On Io, Jupiter would appear 40 times larger than the moon does from Earth. Just imagine what the view of the starry sky would be like there. Io completes a full orbit around Jupiter in just over 42 hours. Compared to our moon, it would take 27 days and 7.5 hours to do the same. As you know, the gravitational pull of the moon on Earth causes tides. There is a similar phenomenon on Io. We're talking about tidal bulges in certain parts of the satellite, which can reach up to 100 meters in height. Since there are no oceans on Io, the upper layers move instead. They rise, then fall, and this happens several times. Io is constantly under the influence of the gravitational forces of Jupiter and its main satellites. Accordingly, the scale of such solid tides is much more impressive than on Earth, because only the moon affects our planet. The temperature both on the surface and inside Io is extremely high. It's the same temperature as lava during a volcanic eruption on Earth. That's why you can observe boiling processes there which force substances to come out, creating volcanoes. No other object in the solar system has as many eruptions as Io. According to estimates, the number of volcanoes on the surface of the moon reaches 450 of them show constant activity. During such eruptions, in some places excessively heated material is released, spreading into space for 320 kilometers. On the surface of the moon, endless flows of magma can be observed, again due to the huge number of volcanic eruptions. As a result, you can find entire lakes filled with lava there. Now let's talk about another moon, Ganymede. At the moment, it is considered the largest moon in the solar system, and it also has the largest water ocean. The surface is covered by an icy crust, which is up to 150 kilometers thick. It is likely that beneath this layer, there could be an internal water ocean with a depth of 100 kilometers. That's 10 times deeper than the Mariana Trench, the deepest place on Earth. During the Voyager mission, ice caps were also observed at the poles. Ganymede is composed of both rocky materials and water, and the layer of atmosphere is so thin that there is no oxygen there. Most likely, there are no living organisms in the moon's ocean waters because there are no suitable conditions for them. On Earth, the situation is different. Even at the greatest depths, there are creatures that have adapted to living in complete darkness. On Ganymede, the conditions are harsher and the pressure levels are much higher. Therefore, most likely at the very bottom, the water turns into ice again. There is no chance for normal life activity there because, for example, geothermal sources like those on Earth won't come to the rescue. The ice layer prevents this. Ganymede also has a magnetic field. It's the only moon in the solar system with this characteristic. This is caused by its liquid core. The object completes a full rotation around its axis in 7 days. The orbit has a rather unusual trajectory, so in certain parts of it, the distance between Ganymede and Jupiter is very small. With their gravitational forces, Europa, Io, and Ganymede constantly influence each other. Their periods of orbiting around Jupiter differ. Callisto is the third largest moon in the solar system. It completes a full orbit around Jupiter in 17 days. The layer of atmosphere on Callisto is quite thin, and the surface has many craters, but the terrain has remained unchanged for billions of years. If any geological processes occur on a planet, they can change the structure of the surface and erase traces of past processes. That's definitely not the case with Callisto. It is believed that the surface was actually completely covered by an ocean, which later turned into a layer of ice. Sometimes meteorites collided with the moon, but there were no other impacts. Nevertheless, we should not forget about the presence of craters there. The largest of them is considered to be Valhalla. Its diameter is 4,000 kilometers, which makes it the largest in the solar system. You can see many rings on the craters. The object that once collided with Callisto was probably very large. This caused the water layers to come to the surface of the moon. There are several hypotheses about the formation of Valhalla. The most common one is that the icy surface of Callisto is quite plastic, and the concentric rings formed like ripples from a stone thrown into water. Thanks to the Galileo probe, we know that Jupiter's magnetic field did not affect Callisto. Perhaps this is because the upper layer there is quite thick, about 10 kilometers, and is difficult to study. We still have a lot of work to do to learn more about this moon. When we hear the abbreviation Unidentified Flying Object, many of us immediately picture the REN-TV intro. But is it really so impossible for uninvited guests to come to Earth, or for them to constantly observe us from a safe distance, like in Stephen King's novel Under the Dome? Is there any real evidence of such contact or the existence of intelligent life? If not, then why? In 1959, the Search for Extraterrestrial Intelligence project was created, which still exists today. Unfortunately, it has to be admitted that when it comes to UFOs, or evidence proving the existence of extraterrestrial intelligence, most eyewitness accounts are either fake or clearly fabricated. Mental disorders among respondents. For instance, hallucinogenic mushrooms can have surprising effects. However, things aren't so straightforward. Let's discuss Search for Extraterrestrial Intelligence's successes and failures. Honestly, since this organization was founded, failures and disappointments have far outweighed successes. One of the successes is the famous WOW signal, received in 1977 using the Big Ear telescope located in Ohio. In analyzing this radio message, which oddly resembled a greeting from extraterrestrial civilizations, increasingly bizarre hypotheses were proposed. The main ones were as follows. The signal was transmitted from a very distant device operating on the principle of a beacon. There is also a version that the strange message was received from a passing alien shuttle. Be that as it may, in almost 45 years, specialists in the network have not recorded anything similar to the WOW signal. This leads to the idea that the radio message might have an earthly origin. For example, it could have been a reflection from some piece of space debris near our planet. But then the question arises, how was the mysterious signal detected on a reserved frequency that is not used by any other radio transmitting equipment? There was also a version that the Big Ear telescope picked up some radiation, but it was immediately refuted. No similar object was within the range of space optics at that time. In 2003, there was another signal, a candidate for artificial origin, caught by the equipment of the Search for Extraterrestrial Intelligence project. The signal was detected at the same frequency, 1,420 MHz, and repeated 3 times, each lasting about a minute, with its source located between the constellations Pisces and Aries. Later, astrophysicists expressed skepticism, claiming that it was either a malfunction of the equipment or background noise coming from some distant cosmic phenomenon. Given all that, is there any real benefit to the search for extraterrestrial intelligence search conglomerate? Overall, the scientific community is condescending but still loyal to this project. It is not funded by the government and usually survives on charitable contributions. Moreover, there is still no scientific program for detecting UFOs. All searches are limited to scanning space or randomly sending out signals. The relative advisability and the very real importance of spreading information about the existence of intelligent life on planet Earth was discussed in one of the videos on our channel, which tells about the original and insightful dark forest theory. In short, some members of the scientific community believe that sending out signals could actually threaten the safety of our civilization. And perhaps that's exactly why we still can't catch a signal from another civilization. Other intelligences simply don't want to be discovered. Astrophysicist Alexander Panasov, a key project participant, is skeptical of this theory. For example, human civilization not only sends signals seeking extraterrestrial life, but also unintentionally provides many reasons to be discovered. We are a noisy planet. Airfield radars, space debris radars. All these objects continuously emit signals in all directions and can be noticed. Panov expands the theory by asking, by whom? According to the dark forest theory, who do we fear? We are afraid of those who might come to us and conquer us. That is, such intelligent beings who are capable of interstellar travel. The level of development of such a civilization must be at least type 2, according to the Kardashev scale. This means that such a civilization uses the energy of its entire planet, as well as the energy of the star it orbits. He believes that for such a civilization, space exploration would be reasonable and straightforward. Of space. At the same time, our radars are capable of detecting such a saucer from a distance of several thousand light years. Thus, the more advanced a civilization is, the harder it will be to remain unnoticed. Now let's answer the question, why? When it comes to UFOs, it always implies the presence of extraterrestrial intelligence. Can the discovery of technological debris of unknown origin be considered an unidentified flying object? An interesting note comes to mind in this context. Experts discovered similar artifacts even in the pre-space era, when there was no stable ring of debris around the Earth. Several meteorite falls during this time were clearly of artificial origin, origins that cannot be attributed to technological debris accumulated by our civilization. After all, such activities were not conducted in Earth's orbit at that time. How can such cases be explained? Official science remains silent for now. What are the main issues in searching for and interpreting UFOs? The main problem is we don't know what unidentified flying objects look like, so we often mistake earthly objects and phenomena for them. This issue is also linked to the failed search for extraterrestrial intelligence. And in this case, no one can clearly define what properties the objects we are searching for should have. And then why did we suddenly decide that some civilization dreams of revealing itself by sending signals and launching spaceships? or is persistently trying to settle new territories by capturing them. We probably draw such conclusions based on the troubled history of human civilization. In fact, the issue of unidentified flying object detection is much deeper than it seems at first glance and raises questions for cosmology. If unidentified flying objects exist, then there is a high probability that they may belong to some intelligent world. From this, we can conclude the universe is full of life. However, why assume this life is like ours? Supporters of the panspermia theory believe that comets are carriers of life spores. Thus, all biomes are likely built from the same nucleotides on a familiar carbon foundation. Further on, the development scenario of such worlds may take a different path, but overall, similar features will remain. That's why we search for UFOs as evidence of intelligent life in the universe, which likely has similar aspirations to actively observe and monitor space depending on technical capabilities, sending their spacecraft to all its corners, capturing new territories, and so on. Nevertheless, it's unclear why so few pieces of evidence of UFOs appearing near our planet have been found so far. If we set aside theories that special services are carefully hiding artifacts from the public, the situation in this regard is rather depressing. However, there are still precedents. For example, in the United States from 2004 to 2021, there were 144 recorded cases of various unidentified flying object sightings that still cannot be explained rationally. The Pentagon has formed a group to study these phenomena, and quite recently in June 2021, United States intelligence agencies published a report analyzing unidentified flying object sightings by American military personnel. It states that intelligence was unable to identify the objects, and the version that these were UFOs is acknowledged as one of the possible explanations. Unidentified flying object sighting data worldwide has been systematically collected since the mid-20th century, but ufology has never been elevated to the rank of science, so most research is conducted almost entirely on a voluntary basis. People also often mistake things like chemiluminescence from industrial emissions into the atmosphere, auroras, meteorological probe flights, unusually shaped clouds, rocket launches, and even the full moon for UFOs. What will happen if we actually receive a signal from an extraterrestrial civilization or discover an unidentified flying object that clearly proves such a civilization exists? Won't this be the kind of collapse we've gotten used to? After all, if people learn we're not alone in the universe, won't they stop caring for Earth? Because you can always run away to some other planet. As they say, home is wherever things are good. However, at this stage, it's more relevant for us to turn to the technical aspect of the question. If an extraterrestrial civilization is similar to ours, then its messages will contain introductory information regarding physical laws, culture, history, and other aspects of the existence of society. This is the type of information people on Earth have sent into space for years. So we've received information from our distant neighbors. What should we do next? The messages are being deciphered, a process that could take years or decades. They're interpreted and ideally woven into culture, forming a kind of cosmic internet. This global formation will inevitably emerge over time, provided that signals are received from different civilizations in the universe. Useful information can be organized as a virtual encyclopedia, expanding knowledge of the macrocosm and its inhabitants. Imagine a cosmic Wikipedia. Does that seem naive or unrealistic to you? Only history will reveal where the truth lies. By the way, receiving multiple signals from advanced civilizations similar to ours, built on a common foundation, would be undeniable proof of the panspermia theory. That is, the fact that life in the universe spreads with the help of spores. And finally, should we respond to a signal coming to Earth from outside? Of course not, because it's absolutely useless considering the enormous cosmic distances and the imperfection of our means of transmission. We live in an era when science is at the limit of its capabilities, and very soon empirical methods may reach a dead end due to a lack of knowledge or the imperfection of the technical base for conducting experiments. Remember that scientists are more willing to consider things that are reproducible, which can be verified and tested. Discovering UFOs or signals from advanced civilizations would spur further development of earthly sciences. A cosmic internet with information on the diversity of worlds would be a valuable source of new knowledge. Should we shut down the search for extraterrestrial intelligence project and dismiss the opportunities to study artifacts that have even the slightest connection to unidentified flying objects? That would be at the very least foolish. By rejecting information that we are not yet able to explain, humanity would become like helpless blind men running into a solid wall. We have many reasons to call Earth the best planet of all, if only because we live on it. And we have enough conditions for a peaceful and calm life. Completely different rules apply on other planets. Our way of life there would not be the same as on Earth. The bodies of humans and other creatures have adapted specifically to life on this planet, so we wouldn't be able to exist as freely on other planets, even if we colonize Mars. At minimum, we need to ensure a suitable temperature, oxygen, and similar essentials. However, most of space still remains a mystery to us. And could there be planets in its endless expanses that boast a greater variety of living organisms? The very fact that life is developing on our planet is, in some ways, incredible. We are able to live normally thanks to the atmosphere, which contains a large amount of hydrogen, nitrogen, and oxygen. We are also lucky to be near a huge star, the Sun, where the intensity of flares is not very high and doesn't have a strong impact on Earth. The size of our planet allows the core to maintain a temperature level so that it doesn't solidify inside. The magnetic field is also very important because it serves as protection from ultraviolet radiation and dangerous solar storms. Don't forget about the importance of our satellite, the Moon, which with its gravity creates tides and also affects the axial tilt of the Earth. Under the influence of the Moon, water in some parts of the planet receded, and many types of living organisms were able to adapt to life on land. About 80% of the Earth is covered by the world ocean. There are warm and cold currents in it that change the climate conditions on the continents. For example, if an area is harsh and cold, a warm current can make the climate milder. This is just the main advantage of living on Earth, but this list could go on for a very long time. The development of life on Earth took place on land, in water, and in the air. It involved not only animals, but also simple organisms. In hot and cold regions, in the depths of the ocean where the pressure is high, everywhere living creatures have adapted to the conditions through evolution. For example, some wild animals like dogs often encountered humans and eventually were domesticated by them. A natural question in this case is whether there are planets in the universe that have more comfortable conditions for life. People who have studied astronomy, or are at least a little interested in space science, know that our Earth is not the most ideal place in the universe. It's not the center of everything, and certainly not the most unique planet. Most likely it's not as perfect as it might seem at first. It has many flaws. Earth can be considered an ideal habitat for humans, but not for living organisms as a whole. In 2013, astrobiologist Rami Kupar-Kaparapu from the University of Pennsylvania published a scientific article. In it, he defined the habitable zone around stars based on current climatic conditions. For example, in the zone of a large star like our Sun, the habitable part extends from 0.99 to about 1.7 astronomical units. From this, we can conclude that our Earth is actually on the border between the habitable and uninhabitable zones. We are really lucky. In this case, for example, Venus, which is our neighbor, has conditions like the greenhouse effect that are completely unsuitable for life. More comfortable conditions for life are found in the middle of this habitable zone. The fluctuations in orbits there are not strong enough to negatively affect celestial objects. Earth can be considered a relatively young planet. Its age is 4.5 billion years, and the emergence of life began even later, several hundred million years ago. Life on Earth will not exist forever. The temperature of the sun is rising, and in about 1 billion years, it will burn everything alive. Then our planet will become more like Venus. But let's imagine, what if Earth had more time and therefore more opportunities for development? Definitely, completely new and seemingly strange species of living organisms would appear on our planet. Believe me, if you saw animals 2 billion years from now, you would be very surprised. In one of the scientific papers called Superhabitable Worlds, the optimal conditions for the full development of living organisms were described. According to this article, if planets are located near stars that are a bit less massive than the Sun, the development of life there will be more intense. The lifespan there is much longer, from 20 to 70 billion years. Stars of this type don't have strong flares. A large number of neighboring planets can also be an advantage, as it helps asteroids deliver vital elements and water. If we rely on the aforementioned scientific work, it turns out that such a system can have several planets with suitable conditions for life. Moreover, panspermia could occur there, the exchange of life forms. Lava eruptions in volcanoes will occur if tidal forces from a planet moon of a gas giant are at work here. There could also be an object like a double planet. In that case, the planets revolve around each other, and during this process, there is an exchange of living organisms. As the size of the planet increases, the intensity of warm and cold currents will rise, and of course, there will be additional areas for the emergence of new organisms. It's important to remember that the variability in planet sizes is limited. If its mass is twice that of Earth, tectonic plate movement essentially comes to a halt. There must be balance everywhere. Also, because if the Earth's crust is too thick due to its size, the core will solidify and cool down. It's extremely difficult for huge planets to maintain a magnetosphere, to keep the gravitational force at the same level as on Earth, but on a larger planet, it needs to be increased by about 40%. Besides these factors that determine how superhabitable a planet is, the presence of oceans is key. 3 years ago, Dr. Stefanie Olsen from the University of Chicago gave a talk at the Barcelona conference. Among other things, she talked about the results of searching for an environment that would be most favorable for the development of living organisms on exoplanets. The experiment used a simulation method with 3D technology. Stefanie Olsen's team recreated the climate conditions on different planets. There, you can learn about precipitation, frequency, and temperatures on objects across the universe. Let's take Earth as an example to look in more detail at how all of this works. The air temperature in the pre-industrial period was about 35 degrees Celsius at the equator. At the poles, this figure dropped to minus 60 degrees. Now let's take a look at Venus and its condition almost 3 billion years ago. At that time, the brightness of the sun was about 20% lower, which created favorable conditions on Venus for the existence of an ocean with a maximum depth of 310 meters. Carbon-based life forms may have existed in this ocean. So far, we don't have direct evidence for this. However, scientists are already searching for possible life on Venus in projects such as Venera D. Here is another interesting planet that is suitable for life. Its central star is Proxima Centauri, a red dwarf. This star is the closest one to the Sun. Because the planet is small, it always faces Proxima Centauri with the same side. This is called tidal locking. It is also known that the planet is in a state of orbital resonance. In other words, for every 2 orbits it completes, it rotates 3 times around its axis. Considering the fact that the composition of this planet's atmosphere is very similar to Earth's, the conditions there become optimal for the emergence of new life. Dr. Stefanie Olsen and her colleagues were able to model the oceans and climate conditions of various exoplanets. On Earth, the intensity of the development of living organisms depends on whether useful elements rise to the surface from the ocean floor and the Earth's interior. Overall, it is obvious that the more cold and warm currents there are in the ocean, the more suitable the planet is for life. Earth has all of this, but is there an object that has surpassed it? Olsen claims that planets with a denser atmosphere and a slower rotation speed have stronger circulation in the ocean. This provides a very important guideline for astronomers when they start searching for the perfect planet for the development of life. In the 2030 says, there are plans to launch some projects that will help us get close-up images of exoplanets with the appropriate characteristics. And it is very likely that our efforts will be successful, and we will be able to find a planet with more comfortable conditions for the development of life. The 20th century was pivotal for space exploration, marked by the discovery of the interstellar medium enabling accurate galaxy maps, the cosmic microwave background radiation, and the universe's expansion. And of course, the first human flight into space and the first landing on the moon. Today, we'll explain how the world achieved these successes. The history of the formation of space science begins around the 18th century. The scientist Isaac Newton played an important role here. He thought a lot about the fact that if a cannon located on a hill fired a more powerful shot, the distance the cannonball would travel would be greater. However, if the force of the explosion reaches a certain point, the cannonball will not just fly at a tremendous speed, it will begin to orbit around. Over time, we found out that this could happen at an altitude of about 160 kilometers and a speed of 7.91 kilometers per second. A rocket could handle such a task. Scientists from many countries worked on inventing modern versions of rockets. The pioneer in this field was Wernher von Braun, a German engineer and also an SS officer. It was von Braun who developed the first ballistic missile, the VD-2. There are many dark spots in this story. This was during the time of Nazi Germany. While developing this, they used concentration camp prisoners for labor without hesitation. The V-2 was able to reach outer space. At that time, World War II had begun, so the rocket served exclusively as a weapon. After Germany's defeat, Wernher von Braun and his colleagues who worked on the development surrendered to the United States. He understood that there were no prospects in his homeland, so he wanted to work for the United States in the future. They, in turn, decided not to lose such a valuable specialist, because von Braun could make not just a rocket, but a rocket with a nuclear warhead. Naturally, the Union of Soviet Socialist Republics disliked this development. Such powerful nuclear weapons gave the Americans many advantages. They had to look for some kind of solution. The Soviet Union acquired some of the V-2 components that were left in Germany. From these, the famous rocket scientist Sergei Korolev created the Soviet version of the German missile. Later on, Korolev created many more similar devices, since after his first development he gained a good reputation with the leadership. One of these was the intercontinental missile R-7, whose flight range could reach 8,000 kilometers. If the fuel level in such a missile dropped to a minimum, the engine and tanks would simply separate from the main part. This way, the missile could travel an even greater distance. The R-7 could not only conquer outer space, but also become a nuclear killer for the United States, working just as effectively as the V-2. The size of Korolev's design was also impressive. The Baikonur Cosmodrome was built specifically for the R-7S. For Wernher von Braun, in the United States, he was unable to fully realize his potential. He appeared on many different television shows, talking about how important it was to explore space. However, the authorities did not allow him to reach his full potential, and von Braun was forced to create only short-range missiles. It was all because of his questionable past. After all, a former German officer was clearly not the kind of person who should make the United States famous as a space power. The rivalry between the United States and the United States Soviet republics in space exploration is commonly called the space race, which began on October 4th, 1957. That was when the Soviet Union launched the first satellite. This happened with the help of the R-7. The capabilities of this device were extremely limited, especially compared to modern developments. But it was a huge breakthrough that was broadcast by the media all over the world. The Union of Soviet Socialist Republics didn't stop there. Just a month later, they sent the dog Laika into space. Unfortunately, the animal died after 6 hours in orbit, all because there were no mechanisms in the spacecraft to return back to Earth. The famous Belka and Strelka were luckier. After their orbital flight, they returned alive. The United States didn't like this situation. The leadership realized that they couldn't boast such stunning breakthroughs in space science. They needed to catch up with the Union of Soviet Socialist Republics urgently. However, the launch of the American satellite was unsuccessful due to the insufficient qualifications of the workers. The rocket fell and caught fire. Then, the United States remembered the experience von Braun. It was he who launched the first American satellite into outer space, just 4 months later than the United States Soviet republics did. At first, these two huge countries measured their military power, but over time, it all turned into a desire to become the absolute winner in space exploration. It was clear that launching satellites and animals in rockets was just the beginning. Soon, a country would send a human into space. The Soviet Union won again. On April 12, 1961, after long and intense training, Yuri Gagarin flew into space. Everything didn't go as smoothly as the newspapers used to say. The hatch of the Vostok 1 spacecraft was not sealed tightly, so the problem had to be fixed in a hurry. When the R-7 rocket, together with the Vostok 1 spacecraft, lifted off, Gagarin said the now iconic phrase, "Let's go." During the flight, he was supposed to report his observations and how he was feeling via radio communication, as well as perform simple tasks like eating food. After Vostok 1 completed a full orbit around the Earth, it began its descent. The braking unit was supposed to separate from the main part during descent, but technical malfunctions prevented this. The descent module and braking unit dangled awkwardly together as if tied by a rope, separating only later. The spacecraft's hull caught fire from atmospheric friction, which was considered normal. Gagarin automatically ejected and landed successfully, although not at the position that was originally intended. Despite some unplanned moments, it was a tremendous success. Unprecedented fame fell upon Gagarin himself. He won many awards from leadership and visited many countries. The United States was dissatisfied with these events, lagging behind the Union of Soviet Socialist Republics and sending their own man into space just a month later. Understanding this, the then President of the United States, John Kennedy, announced the launch of the Apollo lunar program. The Soviet Union already had an impressive list of records: the first satellite, the first spacecraft to reach the moon, the first woman cosmonaut, and the first spacewalk. Landing a man on the moon was, you could say, an unplayed card. The Soviet Union might have led in this too, if Sergei Korolev, the backbone of their space program, had not died. After that, there was another unfortunate incident. The descent module, after leaving orbit, had a parachute system failure, which led to a crash. Unfortunately, the incident claimed the life of cosmonaut Vladimir Komarov. A year later, during a fighter jet test, the first cosmonaut, Yuri Gagarin, also died. The United States, meanwhile, was doing its best to catch up with its rival. The program was still led by Wernher von Braun. Such a complex mission required an especially resilient spacecraft. Billions of dollars were allocated for this challenging task. After many failures, von Braun was able to create what he needed, the Saturn V rocket. Its size was truly impressive. It was like a 30-story building. No spacecraft this large had ever flown before. Subtitles. Finally, it happened. The rocket with 3 astronauts flew around the moon and returned. It became clear that preparations were needed for Apollo 11 to land on Earth's satellite. Edwin Aldrin, Michael Collins, and Neil Armstrong, after rigorous training and preparation, departed for the moon. At Cape Canaveral, where the rocket was to be launched, a large number of press representatives and ordinary people gathered, wanting to witness this historic moment with their own eyes. Apollo 11 orbited our planet, and after reaching the second cosmic velocity, headed toward the moon. It took 4 days to reach Earth's satellite. When the spacecraft got close enough, the lunar module with the astronauts inside separated from the main part and descended to the surface. The fuel supply was limited, so they had to act very quickly. And so, on July 20th, 1969, one of the astronauts, Neil Armstrong, set foot on the surface of the moon. The crew took pictures of the surface and collected soil samples, and finally they set up the flag of the United States there, and a plaque that read, "Here, men from the planet Earth first set foot upon the moon. We came in peace for all mankind." After all the tasks were completed, the lunar module lifted off and docked with the spacecraft. All this time it was orbiting the Earth's satellite with Michael Collins on board. The astronauts spent 21 hours and 36 minutes on the moon and all returned safely to Earth. The people rejoiced, showering everyone involved in glory. Wernher von Braun was proclaimed the father of American astronautics. He fully lived up to that title. After that, he organized 5 more moon missions. They say the space race ended with the so-called handshake in space in 1975, when Soyuz 19, while in orbit, came as close as possible to the American Apollo. Still, there are no losers in this competition. Thanks to both countries, technology has advanced far, and now we know much more about space. If we accept the hypothesis that there are an infinite number of universes like ours, each of them may have its own similar galaxies, black holes, and civilizations. Today, this theory implies that the physical laws in all worlds must be the same, which means the universes are similar to each other, but they may develop differently. Just imagine, in one parallel universe, life on our planet never appeared because of an asteroid impact. In another, dinosaurs never went extinct and became Earth's most intelligent species. And the most amazing thing about this theory is that all these realities exist in parallel, and events in them are happening simultaneously right now. What is the multiverse? How broad is this concept? And what evidence for this theory can we find? It's noteworthy that this term is applicable in many areas of life: science, religion, esotericism, and even literature. At the same time, most scientists consider the hypothesis of the existence of a multiverse with its diversity of worlds to be unscientific, since it cannot be confirmed or refuted through experiments. Indeed, how can we verify whether alternative realities exist? After all, they do not intersect at all, existing either in other spatial dimensions or on diametrically opposite levels. So what is happening in these worlds? Yes, anything at all. In them, you can find your clone, who's either smarter or dumber than the original, richer or poorer, luckier or more unfortunate. You can discover the same life, but following a different scenario, or see worlds with completely different physical constants. It sounds strange. Of course, because so far we've only encountered this in artificially created realities. Konstantin Tsiolkovsky also thought about the nature of the universe. He believed that the macrocosm is infinite, and therefore, the intelligence that develops within it has every chance to become super. That is, to practically gain godlike qualities. This is a somewhat naive judgment, but we have to take into account the era when it was expressed. In any case, Tsiolkovsky's paradox makes us think about the concept of a radiant form of intelligence. If, as the scientists believed, intelligence develops to an infinite level, then what do we get in the end? A deity? Then perhaps the hypothetical multitude of worlds was created by someone intentionally. It's also worth considering what intelligence developed to an infinite level would be like. Most likely, it's something different from the classical interpretation of this concept. It's like comparing a human personality and artificial intelligence, or primordial soup and life itself in all its forms. Of course, you could consider all this idle fiction or the product of science fiction. Among multiverse theory supporters are renowned scientists like Stephen Hawking, Max Tegmark, Brian Greene, Neil deGrasse Tyson, Michio Kaku, Alexander Vilenkin, and others. In fact, if you think about it, even in the world we know well, there are many parallel microbiomes invisible to the eye. Their tiny inhabitants, though minuscule, can kill those unaware of their enemy. For example, Herbert Wells noted this bacterial trait in The War of the Worlds. Modern science fiction writers, such as Liu Cixin, have gone even further, suggesting that life could exist even on electrons and atoms. We are likely as amazed as the scientist who first looked through a microscope and saw a whole world on his fingertip. But let's get back to the theory of multiverses. If we take the cosmological paradigm into account, we should immediately dismiss fantasies about wormholes and portals. It is believed that such systems have geometric unity, meaning that you can draw a straight line between the many universes in this conglomeration. At the same time, the properties of each world differ, sometimes drastically, sometimes only slightly. To exaggerate and give a simple example, in one universe your middle name might be Ivanovich, in another it could be Vasilyevich, and in a third world you might be born on a completely different continent. These patterns are very simple but provide a full understanding of the overall composition. The described set of biomes should not be confused with the quantum multiverse. What is that? This is a micro-world inhabited by gluons, photons, quarks, electrons, and other weightless particles. Completely different laws operate within such a universe. As paradoxical as it may sound, every particle in such a world must be considered as a wave. That is, mathematically, it is described not as a point, but as a wave function, simultaneously existing in all locations along its trajectory. Thus, it is possible to predict its location at any given moment in time, as well as calculate the parameters of these particles, such as momentum, the amount of energy released, or spin. It sounds exotic, and yet humanity is already using the quantum multiverse to solve pressing problems. Thanks to ultra-precise calculations, lasers, microscopic electronic systems, and fast internet work. However, if we move on to the theory of multiple universes in our familiar macro world, the question arises, how did they appear? The Big Bang is believed to not have been the only one. These grand events periodically occurred in different locations. Thus, it is possible that in some universes, planets have not even appeared yet, or on the contrary, civilizations have advanced to the third and fourth levels on the Kardashev scale. It turns out that our global world is just an atom in the titanic body of the multiverse. This theory is seen as scientific, especially by scientists like Reese Martin and Andre Lind. The problem is that we still can't detect the moments of emergence and development of neighboring worlds. But if we establish a solid theoretical foundation for all this, then over time we will have to take such universes seriously and perhaps even adjust the familiar laws of physics. Is it possible to obtain at least minimal evidence for this theory right now? It turns out yes. What is the space-time continuum? It is believed to be an invisible membrane that stretches on forever, but that's not the case at all. The number of possible particle arrangements is not infinite. Eventually, everything will repeat itself, so you would inevitably encounter your own double, and that's no longer just idle fantasy. It turns out that our observable universe extends about 14 billion light years, the distance that photons of light have traveled since the Big Bang. And what's around it? Emptiness? There, most likely, like patches of a boundless quilt, an infinite number of neighboring worlds are located. Is there anything even more amazing within the topic of multiverses? There is also the bubble universe theory, which is based on the expansion of space similar to balloons. This hypothesis was proposed by the cosmology specialist Alexander Vilenkin, a researcher at Tufts University. He believes that there are regions in space that at some point stopped expanding or are in the process of isolating themselves. These regions make up a multitude of neighboring universes. They may have conditions that are absolutely anomalous from our point of view. This especially fuels astronomers' interest in indirectly studying strange and mysterious objects, even if they currently exist only at the level of hypotheses. Continuing the discussion about multiverses, I want to ask, which theory is the most difficult to understand? We can't help but mention it. As you've probably already guessed, it's string theory or brain theory. According to this theory, the universe is made up of strings of energy, just like the different vibrations of strings on a musical instrument create music. The different ways these strings of energy vibrate give particles their unique properties and ultimately give rise to all the fundamental forces in the universe, gravitational, electromagnetic, and other types of interactions. As a result of mathematical calculations, Dijo Polchinski and Rafael Busso from the University of California found that the main equations of string theory may have an astronomical number of different solutions, more than 10 to the power of 1,000. To help you grasp the scale of this number, let me give you one fact. The number of atoms in the entire observable universe does not exceed 10 to the power of 80. Each solution to these string vibration equations represents a unique way to describe the universe, and all of them will be correct. This scientific hypothesis is based on the idea that the world is not limited to 4 earthly dimensions. It is multi-dimensional. By the way, Kardashev was convinced that all the most advanced civilizations had long since moved from our universe to more advanced worlds. No wonder there's radio silence around us, and despite efforts to find extraterrestrial civilizations, we find nothing. To sum up what has been said, it's worth mentioning the classification by one of the proponents of the multiverse theory, Max Tegmark. He divided worlds into those that are beyond our cosmological horizon, that is, beyond the observable universe, those that are based on different physical constants or quantum mechanics, and all these universes as a whole gathered into a mega conglomerate. It would be interesting to see this myself, but few world walkers exist, and none of us can cross between worlds. We can only hope for the role of the travelers. That's the colloquial term for characters who accidentally go on a journey not only to other universes, but also to the past or future of their own world. Do you believe in the multiverse theory, or does it seem too fantastic to you? If you want to learn even more about the world around us, stay tuned for updates. There's a lot of interesting stuff ahead.